Okay, it's Mr. McTavish, and this is just a short video showing how to design a catapult. So first things first, the game is Rapid React, and when we look through the manual, we can see 5.7 is cargo. So 9.5 inches in diameter. So let's start with that. So what we'll do is we'll just use the front plane for our sketch, and we'll just create a circle that is 9.5 inches in diameter. So there's our circle. And to make this into a three-dimensional shape, we're going to create a line that cuts the circle in half. You'll notice that when I was creating it, that little orange dotted line showed up, which indicated that it was going to be vertical compared to the origin. So that way it's right through the origin. That's perfect. And I'm going to revolve. And for the revolve, I'm going to revolve that half. And the axis is going to be that axis. So there's my three-dimensional shape. Okay, so what I'm going to do now is I am going to just going to hide that for now and include that sketch. So this sketch, let me just rename that. That's the ball, and I'm going to do a new sketch. And I'll use the same plane. That's great. Now for this plane, basically I'm going to want um, a piece that is going to go underneath. So I'm just going to select that. Now, I'm going to turn that into a construction line because I don't want it. What I want to do is I want to create an offset. So I want to create a circle that's not a construction circle. And it's just a little bit bigger. I'm just going to go 1/8 of an inch bigger than that. That way there's just a little bit of room, but not too much extra room. So this is going to be my catapult. So what I want to do is I'm going to use that, and I'm just going to offset that a bit. And instead of 1/4 of an inch, I'm going to do 1 inch. So I'm going to have a piece that is going to and I'm going to make this horizontal to that point. There we go. So what I'm doing now is I'm going to mirror this. I've got that. I'm going to chop that off. Whoops, didn't want to chop that off. I'm going to chop that part off. So now I have something that is going to be used. And what I'm going to do is I'm just going to create a rectangle here. So this rectangle, let's go 2 feet. The reason I'm doing 2 feet is it's got to fit on the robot. And right now, if I'm picking that line and that's 35 feet. That's going to be too big. So I'm going to switch that. Let's try 18 feet. And we'll just set that to be a good. So there we go. So we have that, and now this distance, that's going to be 28 inches. That's 28 and a quarter. That's great. That's not too bad. And what I'm going to do is I'm going to add a midpoint here. And that midpoint is going to be horizontal to that. Okay, so there's 18 inches, and it's 1 inch. So this is going to be the, the square tubing that this is going to be attached to. So what I'm going to do is I'm going to add some holes centered on here. So this is where I'll put my bolt, and I always need at least 2 of them. And they're equal in size, so I'm using the equal constraint. And these are going to be 1/2 inch from there, and then that one will be 1 inch. So very standard sizing. And what I'll do is I'm going to just create a little tangent arc right there, and a little tangent. And I'm going to just set that. So I have my shape. So this so the idea with this is that let's extrude, but we're not going to extrude everything. We're going to extrude that, that, and that. And just looking at that, this is going to be pretty. So what I'm doing here is just smoothing that out. So we're pretty good. So there's our shape. Now my extrude is obviously way too thick. So that's going to be 1/8 of an inch, and it's going to be symmetric. So that's going to be right smack dab in the middle. And the reason I'm doing that is because I'm going to create a new sketch using that face. And I'm going to just use that, and I'll need to create a circle right there. Now, I'm just going to escape that, because what I'm going to do is I'm going to make that circle this will be my pivot point. So I'll get, there's going to be a lot of force on this, so I'm going to I think I'll do a half inch, and then that way I can put a bushing in so that I've got it. So there's my shape, 1 inch. And you can see I've all of a sudden got this started, and I have a piece of plastic that's going to hold the ball. If I create an assembly, including those things, and I'm just going to fix, and I'm going to group those. What I can do is I can add another piece that's going to go here, that's going to attach to the ball, and that way I've got 2 points of contact for the ball. I may want to add some spacers. So I would add some spacers to that I would 3D print and put bolts in to hold these together. And I may add some other spacers so that I can get the ball. Let me just. So I would have the other one right there, and then another spacer so that I'd get, and I'd have to work out the geometry of that. But if I'm looking at it from an inch or so, I can figure out exactly where it is and do that. So all of a sudden, I've got a scoop mechanism. I have a pivot point, so I would need to have something that this would pivot on, and I just have a 3/8" hex rod through 2 bushings in there, so that would pivot on that, and I would then add some holes on the top here and all the way through. And those holes I would go to Home Depot and find an eye hook. And but what I'm looking for is I've got to find the right term, but it would be a hook like that, where it's, and so it would bolt through, and then that would be what I would tie on the plastic or the surgical tubing, and I would tie the surgical tubing to a point over here, and so that when it's up like this, it's tied tight. So pull it back, it's going to have a lot of force, and then release it. For a prototype, that's all I need. If I was going to do this in real life, then I would, like on a robot, then I would attach a string here or something that would allow it to winch back. And then that winch would have a locking mechanism so I can drive around. And when I'm ready to shoot, it releases the locking mechanism, and the surgical tubing shoots it forward.